The goal of this video is to show you how to code a 2D array of masses. We've been doing basically 1D problems up till now. Now we want to do a 2D problem. So just a second here. Okay. All right. So let's just start simple. Let's say we're going from -5 to 5 by 1. Actually, let's say negative. Yeah, that's fine. Who cares? So this means go from -5 to 5 by 1s. And let's say ball equals a sphere. And let's say ball dot pos equals actually, let's just do it this way. Oh, yeah, let's do it this way. So let's say ball dot position equals a vector, x, comma, 0, comma, 0. And then let's run this just to see what we get. All right, so we've got this array of spheres. Cool. All right, now, what if we want to do a 2D array? Well, let's think. We need both the x and the y coordinates to change. So you might think we could do something like this. Now let's say I want to do the same thing for y in that same range. Okay. Now here we run into an issue. Keep in mind, after this colon, everything gets indented. So now we come through this line where this colon implies a second level of indentation is required. Now, in this case, if I run this code, it's still only updating the x equation. So we got to remember to also put in the y position. So when I run this, let's see what happens. There we go. And so if I could, let me scroll down a bit. You can see we get this square array. And notice it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 by 10. All right, so that's cool. And then what if we wanted to actually deal with these things later? It could be tricky. So we might want to make an array. And in this case, I'll call it a plate. So this, a list. So in this case, we're going to make a plate and we're using the square brackets. So that means plate is a list. It's an empty list. So then we could say plate dot append ball. All right. And let's see here what we've got. And then just to make sure it's working, notice I have to unindent 2 tabs. We could then stick in another lever of code. And since now I'm no longer indented, I'm out of that, we could start a new for loop. Oh, let's do this one. How about just... And so we could do this. And notice, even though we've created this list, which made a 2D array, essentially, it's all in a single list. And so what this will do is this next line of code, it will go through and look for a ball that's inside of a plate, right? Or it will look for an object and we'll give that, whoops. There we go. It will look for an object it decided to call my ball that is in this plate. Well, that plate is that list. And so hopefully this will give us whatever we have here, about 100 values. All right. And so if I scroll down, we could see that it's giving a whole bunch of values. All right. And so just looking at the 5s, notice there are more. Let me scroll down even more here. Let me do this just to make clear I'm not making this up. Notice the x value, it has all 10 objects that have an x value of -4, all 10 that have an x value of -5, etc. So it is going through the entire list. All right. And so this is a convenient way you could use this to draw objects in there and refer to them later. Great. There is another way to do this in NumPy, and that's different. I don't want to talk about that right now. But what if we want to subject this to a constraint? So let's say, now I'm going to stick it a constraint here. Let's say if, let's see, how about we only want to draw the balls if, let's do this. Let's pick a Y value. Let's make this easy. So now the Y value is going to start at 0. Okay. So, well, before I get too far along, let's run that and see what it looks like. Sorry about that. Okay. So this should cut it in half, hopefully. All right. So we just see the upper half now. And now let's say I want only some of the values to use. So if the Y value is greater than X, whoops. Okay. If the Y value is greater than X squared. So the star 2 here is, you might think this is the squared operator, but it's actually star. So that means if Y is greater than, oh, let's do this. Let's say if it's less than or equal to X squared. All right. Now I'm going to put another colon. You know what that means. If there's a colon, I need another level of indentation here if I want this to be inside of that. All right. And so what is this code going to do? Let's walk through it one step at a time. First, it creates an empty list. Then it creates a new parameter X, and it lets X change. It's going to start it at -5, and it's going to go to 5 by units of 1. And then maybe to speed this up, let's make this go from 0 just to speed this up. So now we're going to start the X and the Y at 0. So let's say we go from 0 to 5 by 1s. And then it creates another parameter inside that for loop. Okay, so it's creating a new parameter Y, and it's going to let that parameter range from 0 to 5 by 1s. The first thing it does inside of there is it says check. If Y is less than or equal to X squared, then do this stuff. Otherwise, it's not going to do it. And if you're curious, we could even stick in a line else, or you could say elif if you wanted a second if statement, but let's just say we want else print Jorstad. Okay, so let's say we want it to do this. So now what should happen is if this condition is met, it will do this. Otherwise, it would print this. So starting with X, we know X is equal to 0. All right. Y is equal to 0. First check, is 0 less than or equal to 0 squared? It is. So then it will execute this. It should draw a ball at the coordinate 0, 0. Then it comes down to here. Well, this didn't apply. So then we're done. This is not indented. So that's the end of the loop. It comes back. It next increments the Y loop. It does not change the X loop yet, right? So now it's going to do the next level of Y. Y is equal to 1. So 1 is not less than or equal to 0 squared. Remember, right now, Y is now 1. X is still 0 because we haven't gone up 1 yet. So we're still in this for loop. Let me put it like this. It's a little bit weird looking at it. Basically, this is the if-else statement, and that is contained in this loop right here. All right. And then that loop is contained inside of this. So first it will do everything in the innermost, then it will go to the next level out, and then finally to the outermost level. So as it goes through, the next time Y is 1, 2, 3, 4, 5, none of those, so it won't draw a sphere. Only then, after we've gone through that entire level of Y's and it's exhausted that, it then steps into the X loop and it says, oh, well, now I can increase X by 1 and do it all over again. And so when it does this, let's see what we get. Hopefully it looks something like a, oh, and remember I was getting this error. So let me do this. Let me refresh. Sorry about this. There we go. Whoops, looks like it didn't get it. So let me go here. All right, sorry about that. Okay, now I got to redo those indents. Sorry about that. All right, so just making sure we're going from 0 to 5, 0 to 5 by ones. We're checking this condition, doing that. All right, looks pretty good. Let's run it. Okay, and so this looks kind of funky here. Oh, I forgot the less than or equals to. There we go. Sorry about that. And so it's starting to look a bit like a parabola here. And in fact, we could even do this and change that parabola and basically type in different equations here and make different shapes. And so if we take this up to a smaller increment size, it should look a lot better. Let's say we go by 0.25s. And so in this case, let's see what we get. And it starts to look pretty smooth. And obviously you could change the parameters of the ball, the size. Maybe if we change the size of the ball. All right, we might start to make this look pretty smooth. And so, okay, great. And you can start to see this pattern. Obviously, we could make this approximation better and better, but you could see, hopefully you could see, oh my gosh, if Zoom ever catches up here. Trying to annotate, but it keeps lagging. Oh my gosh. This is lagging really hard right now. Sorry about this. But there's the parabola that we were trying to draw. That's that y equals x squared parabola here. And there was some prefactor on it. Okay, very cool. That's it for now. That's how you could do 2D arrays. Hopefully you could use this to do a 2D center of mass calculation. All right.